So, dear student, today I'll be discussing, especially the last chapter is 20 marks. There is application of partial differential equation which involves the Laplace transform as well as the Fourier transform. So, I'll be discussing two important questions. So, yeah, I think you can see the screen now. So, this is our first important question. Let me come here. As you can see with my arrow, solve the differential equation they given. Conduction of heat along a road with a radiation subject to the condition they given. Correct. So for doing these kind of questions, first thing is we have to know what the one-dimensional heat flow equation. Okay. So basically the one-dimensional heat flow equation is what? Dou U by dou D is equal to C square dou square U by dou L square. And the solution of the heat equation we'll apply in the problem. If you are not going through this, then we can never ever solve the problem. Okay. Or else whatever I teach, you will not be able to understand. So this is a little bit difficult topic. In the sense, we have to know the derivation also. That's the reason I'm telling. Okay. So as you can see here, u of x comma t is equal to x of x or t of t. Correct. And xt dash is what? C square. Correct. X double dash of t. Correct. Then what I'm doing, I'm taking x on the other this side. X by x double dash or x double dash by x. Rest everything in the other side. I'll be getting this. So all of these things I will be using it what in the problem. And then again coming to here, d square capital X by dx square minus kx. Okay, equal to 0. dt by dt, this capital T, dt by dt is equal to minus kc square t is equal to 0. So when the k is positive, we'll get what? This equation. C3 e c square p square t. And when k is negative, I'll be getting what? Cos px and sin px. When k is 0, I'll be getting x plus c8. So all of these things we have studied in our first semester basically. Okay, so those things we are going to use in our M3. And finally, these equations, the various possible solutions. So we should not get, so if the first condition is satisfied, this equation will come. Second is satisfied, this one will come. Third is satisfied, this one will come. Just substituting all of those things. Now if I'm going to apply, correct, then I'll be getting what? We choose the best solution which is consistent in physical nature. Conduction of a heat along a road without radiation. And they given a condition. They used the road is not infinite, correct? And they given some boundary condition. This is called the boundary condition. Second one is we like x minus x square. For 2 is equal to 0. So in the sense, boundary conditions of the road. So as I already told you, the first step in the heat equation, I'll be using this x double dash by x is equal to t dash by alpha square. You can just back the video a little bit and you get the same equation where I told in the beginning only. This I'm assuming is minus k square, correct? This also I told you the solutions. C1 cos kx plus C2 sin kx. So whatever I am discussing, there is just the one-dimensional heat equation only. So I am getting this equation. So whatever is there in the one-dimensional, that I am putting it. In the sense, the last three equations I told, right? Which is the best possible we can take it. Correct. That same thing I'm writing it. Same thing you have to by heart and write it. Okay, because that is basically the one-dimensional heat equation derivation. But end of the day, we will not get a derivation, we'll get the application-based questions. We will get the same question, so better to study that. Then whatever is in the question here, just apply it, t to infinity. Correct. So capital T also I'll put into infinity. Okay. Then what I take here is, I take what? The second equation, C1 cos kx and C2 sin kx. Okay, this is the condition, correct? This is the condition which I am taking. So this condition I'm neglecting. Which one? Third one. Okay, so second and fourth I am taking as the best possible condition. Then I'll take u is equal to what? Xt, correct? And this C8 and C9 is there, right? C8, C9 usually xt. X is this, correct? And T is this. And this C7 is there, no? That I'm making as what? 0. That is the initial boundary condition I'm applying in this. This I'll make it as A naught. So what I'm going to do is when I'm differentiating this, in the sense if I'm differentiating this particular thing, what is cos differentiation? Minus sine kx, correct, into k. Sine kx differentiation is what? Cos kx into k. So that k only is here, this k. You have to do it, you have to write it down in your notebook, then only you'll be able to get the flow. If you randomly listen to this, we'll get sleep. Okay, so we have to note it down parallelly because this is for 20 marks, 10 marks each. Fine? Yeah. Then C3. So I'm just differentiating all of those things. E power minus k square alpha square t. That's a constant. This I'm not going to do anything. This one, this particular thing. T is C3 power minus is there. No, that same thing I'm going to put it because it's a constant. It has got nowhere related to x. That's the reason I'm putting this t here. This is basically u is equal to xt. Now I apply what? Put C2 is equal to 0. If I'm putting C2 is equal to 0, that is the boundary condition. This will be what? Minus C2 is equal to minus C1 sin kx plus C2 cos. Correct? Kx is equal to 0. So instead of x, I'll put as L because the condition is what? Go back to the question. X is 0 to x is equal to L in the first and second. You can see here. Dou u by dou x equal to 0 for x is equal to 0 and x is equal to L. Okay. And how did this become 0? I'll tell you. C2 is 0. So this term is entirely gone. Correct. KL is equal to sin KL is equal to 0. You might be wondering how KL is equal to n pi k. KL is equal to n pi k because you can see here, right? Sin KL is equal to 0. What is sin n pi value? 0. Okay. Sin KL. Let me see whether I can draw it in text here. Hmm. I'll write down here only. Sin KL is equal to 0. Correct? So instead of 0, I already know what sin n pi is equal to 0. Sin n or sin n pi is equal to 0. Sin n pi value is 0. So that's the reason sin and sin is getting cancelled. Okay, sin and sin is getting cancelled. If it get cancelled, what it will be? KL is equal to n pi. That's what they written down here. Where is it? I think I am writing it top of it. Here, KL is equal to n pi, as you can see it here. This part. So then coming to the next one, u is equal to C1 cos kx. Because C2 value is already 0. This is already done. This is already done. Correct? So this is already done and just substitute the above equation. Here, C1 cos kx. C2 value is already 0. And T is what? C3 power minus k square alpha square T. U is equal to what? Xt. U is equal to again xt. So all of these steps they have missed it. Okay. So this is basically an cos n pi xl by L e power minus n square pi square alpha square t by L square. That in our Fourier series we got a formula, right? An cos n pi x by L That same thing only they're going to put it, but they're not done it. This is a general solution which you have to remember. E power minus n square pi square alpha square t by L square. Okay. So write down this up to 2 to 3 times. Then only you'll be able to memorize this. It's a kind of derivation only. Then we will be getting general solution usually a naught plus sigma Fourier series, basically. Same thing. Then we will use the boundary condition now. Condition 3. Lx minus x square is equal to a naught plus this n pi xl by what? L. In the sense I am putting what? N is equal to 0. If I'm putting n is equal to 0, this full term will be gone. Or else I can put x also is equal to 0. Because the series is what? 0 to L. So a naught is nothing but 1 by L integral 0 to L. Lx minus x square. Fourier series. Simple Fourier series. And a n is equal to what? 2 by L, 0 to L. Correct? 2 by L, integral 0 to L. Lx minus x square cos n pi x by L. So this again I have to apply what? By parts or Bernoulli's trials. First function integral of second function minus differentiation of the first function into double integral of the second function plus triple differentiation of the first function into triple integration of the second function. So I hope everyone knows it. Yes, and then I'll be getting this. And if n is even, I'm putting n is equal to 2f. That's all. Then whatever I get a naught and a n value, whatever I get a naught and a n value, I'll substitute in this above equation. That is our final answer. This is one 10 marker question. Okay, so it's very, very important.